good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to start learning about the wonderful world of exponentials and logarithmic functions. It's good stuff, powerful stuff. If you've ever put money in a bank or used a credit card or borrowed money from your parents and you got to pay them back, or if your parents have a mortgage or bought a car, exponents were used a lot in the calculation of interest and payments and balance. So there's a lot of useful financial stuff here with exponentials and with logs. So let's get right to it. Exponential functions, my friends. The general form of an exponential function is y equals a times b to the x power, where a cannot equal 0. Okay, if a equals 0, 0 times anything is 0, and then all you have is a constant function of y equals 0, which is a horizontal line going through the x-axis as so. So a cannot equal 0. B has to be greater than 0. Okay, it's got to be greater than 0. It cannot be a negative. And it cannot equal 1 either. All right, so it has to be greater than 0, but it cannot equal 1. How come? Because what's 1 to any power on Earth? It's going to be 1. So we're not really seeing any growth or difference here. So that's an exponential function, guys, in a nutshell. The A is the original amount, the beginning. Sometimes it's called the principal. Sometimes it's called the initial amount. It's what you start with. If you guys have ever seen a movie on dinosaurs, like, you know, the Jurassic Park series, stuff like that, they use carbon dating. Well, carbon dating has to do with exponents and the amount of carbon that is left inside of a fossil, okay? Well, there was an original amount of that fossil. That would be your A. Or if you're going to put money into a bank account and they're going to pay you interest and you deposit $3,000 to start with, that would be your A, your initial amount, your principal, okay, what you started with. B is either, guys, the growth or the decay factor. What are you talking about? Well, when we're dealing with percentages, guys, we can either have a growth where there's an increase in percentage every month or every day or every year or every week, every certain time interval, or there could be a decrease in percentage. For example, a car. Best example. Guys, on average, okay, and everyone likes cars and it's nice, but on average, the moment that you signed your name on that piece of paper, get into your car and drive off the parking lot, you have lost 20% of the value of your car right off the bat. What are you talking about? Well, what I'm talking about is if you go and buy yourself a $100,000 car right now and you walk out the door, I promise you, you can sell it immediately for $80,000, not $100,000. It's called depreciation. Well, that loss, that's what this growth or decay factor is. There's a decay factor in cars. Cars are not an investment. Now, some of you are going to say, whoa, what about antique cars? Antique cars are antique cars, and that's a separate market. That's more of an antique value than the car value itself, okay? So growth or decay. If B is greater than 1, that means you had a growth. That means that you had 100% of the original amount plus some R. What is this R? This R is that rate of percent that's increasing the value of your original investment or your original amount. Okay? So when you have a growth, you have a R that is a rate of increase or a growth rate. This is the percent by which your whole investment or the original amount of what you have is growing at a constant rate. When B is between 0 and 1, okay, it's a decimal. That means that it is a decay. That means that you took 100% of the value of your original amount and you subtracted that percentage rate. So 1 minus any decimal is going to give you a decimal. So that's why b is between 0 and 1. All right? Now, exponential growth, you can see, we always read graphs from left to right. Bam. There it is. Now, you may see this and say, Moro, you're wrong. This says y equals a to the x. No, I'm not wrong. They just don't have a leading coefficient, okay? Sometimes in books you'll see a's and b's differently. Please note that my formula, there's nothing wrong with it. All my formula does is it articulates the fact that there's some, I'm sorry, did that wrong. All my formula says, let's try that one more time, guys. Sorry. Thank you. Thanks for your patience. All my formula says is that there is a number, a coefficient that could be in front of that b. But that b is really the growth rate. Here, they call it a. It's the same thing. They just don't have the coefficient. I don't want you to think that it's different or wrong. If I have an exponential decay from left to right, then I am going down. Think about it logically. In an exponential growth, my original value, my original amount is increasing. Hence, from left to right, I'm going up and up and up. In an exponential decay, okay, my original value is decreasing. It's going down, 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 down. Notice, though, that your amount will never, ever hit the x-axis. It'll never hit 0. Even a car. Let's say a car can't even start. It's got no tires. The engine's gone. The windows are broken. The seats are destroyed. It is just going to go to the junkyard. They're still going to give you something. Maybe a couple bucks. Not bucks, a couple hundred. Maybe 150. Maybe $40. But you're still going to get something for that. Okay? So the value, the original value, will never be 0. Now, yes, sir, my brother. Yes, cars are not an investment. Very good question. What is an investment? Real estate. Real estate, for the most part, is an investment unless you're in a market crash, in which then it's, it could get a little bit hairy. However, in the long run, though, real estate never loses. So if you buy a property for $1,000 today, in the long run, by law of averages, 10 years later, you're going to have made money. 1 year later, you're going to make money. So things that are real, that have a real value, are investments. Stocks, buying into a company. That company has a real value. That can be a growth, but that can also be a decay as well. So there's nothing constant that's always growing except for real estate, and that's in the long run. Because back in 2009, we had the market crash. So people that maybe bought a house for $1 million, now that house was worth $300,000. That's a $700,000 loss. That's not a good investment. But that was because the market was all crazy. So these are good questions that you want to ask as far as investing in a business. Pick up a business book or a business magazine, investment, go on Google, and there's experts that can help you with that. But this is how they calculate it, okay? Now, if I want a graph, guys, it's just like anything else. I make an X and Y table, and I literally graph. Simply create a table of values and use the domain of -1, 0, and 1. Don't use the moral 5, just use -1, 0, and 1. Because the pattern of a exponential is never going to be different. This pattern that we saw, that's how it has to look. If it's a growth, I got to be going up from left to right. If it's a decay, I've got to be going down from left to right. So always keep that in mind when you're doing this. So here, let's go ahead and make a table. So I'm going to make a table right quick. Very simple, x, y. I'm going to go -1, 0, and 1. When x is -1, I've got 3 to the -1. If you remember, that becomes 1 over 3. Because whenever I have a negative exponent, I can bring it down to make it positive. So that's 1/3. When x is 0, y is 1. And when x is 1, y is 3. So go ahead and graph it. Let's see if this is correct. Negative 1, 1/3. You're going to have to estimate there. 0, 1, and then 1, 3. And that's about right. Bada bing, bada boom. Please do not cross the x-axis. Please do not cross the x-axis. Makes sense? Now, in my graph here, it says, remember that the asymptote is the x-axis. Okay, let's explain that for a second. An asymptote, guys, is an invisible barrier that a graph is not allowed to cross. Okay? How do you know that it's 0, Mr. Morrow? Because there was nothing being added here. Do you guys remember the h and the k? Remember the h and the k from quadratics, guys? That the h moved it left and right, the k moved it up or down? Well, the k determines the asymptote here. So what am I talking about? If I give you something like this, actually, hold on, let me just get a new page. If I tell you to graph y equals, let's say, 2x plus 3. Well, what's going to happen here is at your 3, there's an asymptote. I cannot cross beyond there. Okay? That's where my asymptote is. So when I made my table, I would still make my table x, y, negative 1, 0, 1. When x is negative 1, 2 to the negative 1 is 1/2. 1/2 plus 3 is 3.5. 2 to the 0. 2 to the 0 is 1. 1 plus 3 is 4. And 2 to the first is 2. 2 plus 3 is 5. So here, we got 0, 4. We got negative 1, 3.5. And we've got 1, 5. 1, 2, 3, 4, and 5. And check it out, guys. It works like clockwork. This guy here, that K, that determines your asymptote. Beautifully put, sir. The K is like your new x-axis, and you can't cross the x-axis. Very good. That's brilliant, son. Thank you, my man. Great job. Does that make sense, guys? Yes, sir, my brother.
What if the 2 is negative?
If the 2 was negative, okay, let's just go ahead and do that in blue, okay? If it was negative, let's see how it would affect the y here. If it was negative 1, negative 2 to the negative 1 power, I'd have negative 1/2. Negative 1/2 plus 3 would be 2.5. If I had negative 2 raised to the 0 power, that'd be, no, it'd be negative 1, right? Because when I have negative 2 to the 0 power, remember, who's being affected by that x? The 2, not the negative. Right. So this would be negative 2, right, would be negative 1, and negative 1 plus 3 would be 2. Wait.
No, it would be, the answer would be negative 1.
No, that's what I thought. Yeah, negative 1. Thank you.
It's 2 to 0, which is
Correct. And this one actually here, hold on. That'd be, no, yeah, that would be correct. That'd be 2.5. And then when x was 1, negative 2 to the first is negative 2 plus 3 is 1. So this would look like this, my brother. Negative 1, 2.5, so it'd be about here. 0. Negative 2 to the 1 is negative 2, plus 3 is 1. That's okay, my brother. Thank you for caring. 0, negative 1. 0, negative 1. And 1, 1. Wait, this is wrong.
Yeah, because it shouldn't be negative 1, it should be 2.
This guy here?
Because it's negative 1 plus 3 is 3.
Thank you. Thank you. So, okay, here. And then we got 1, 1. Which is right here. So it would go down. So when it's negative, it's inverted. It goes down. That's a reflection over that axis. Okay? So be careful, guys. The K, that's going to tell you your asymptote. All right? I'm not going to kill you with this, but you got to know how to recognize it. You feel me? Now, the more practical stuff than graphing is determining if you have a growth rate or a decay factor. So determine the given exponential functions determine if they are growth or decay. Then find both the growth or decay factors and the rate of growth or decay. Okay, so is this a growth or a decay? Okay, this is a decay, guys. Now, what is the decay factor? The decay factor, thank you, is 0.85. That means that my original amount of 7, it's 85% of it every X unit of time. Now, that's my decay factor. What was my rate of decay? What's the R that I subtracted from 1 to give me this 0.85? What is it now? My rate of decay? Yeah, it's 0.15. How did you get that? Well, I went 1 minus 0.85 and 0.15. Make sense? What about the next one, guys? Is that decay or growth? This is growth because it's greater than 1. Okay, what's my decay? What's my growth factor? That's right. My growth factor is 3.2. What's my rate of growth? Would be 2.2. How did you do that, Moro? Because 3.2 minus 1, 2.2. That was my rate that I added to my original amount, and now I have a growth factor or a decay factor, depending on if I added or subtracted. Does that make sense? Yes, sir, my brother. I'm sorry, my man? The y equals 5. Well, what I did was, first of all, I noticed, thank you for your question, that's above 1. So that told me it's a growth. And then now, what is the growth factor? Well, it's growing at 3.2 of the original. And then how did I get my rate of growth? How did I get to that? Well, I went ahead and said 3.2 minus 100%, which is 1.0. So I added 2.2 to my 100%, and that is my rate of growth. It's growing by a rate of 2.2%. Make sense? Yes, so maybe kind of, sort of? Thank you, my brother. So now, you contribute $2,500 into a college savings account for 3 years. The account pays 7% annually. How on earth would you set this up? Talk to me. Y, which is the amount that you're going to have at the end of all this, equals my original amount, 2,500. That's my A. Good job. Yes, sir, my brother. Close. It'd be 1.07. Because remember that it's 1 plus the interest that I'm earning. Remember that this 1, guys, this is very huge concept. This 1 here represents 100% of my original amount. This 0.07 is 7% of the original amount. So together, if I have 100% of the original amount and 7% of the original amount, then I have in total 107% of the original amount. And then I'm going to raise this to the x power, right? Which is my time, and time here in this case is 3. Now here, guys, you're going to need a calculator. You don't need it, but it's going to make life a lot easier. You can totally do this by hand. When I was a kid, I did this by hand. It's not a big deal. But time's sake, we're going to go ahead and use a calculator. Please be very careful when you do this in a calculator, guys. Okay? This is y equals 2,500, so you can go ahead and put 2,500 in your calculator, times, open a parentheses, guys, follow what's on the paper, put it directly on your calculator. So you got 1 plus 0.07, so put a plus 0.07, raised to the x power. So you close your parentheses, you raise it. On the calculator, if you use the one I bought, There's a little button that looks like this that raises to any power you want. Put a 3 as your exponent, and the answer you should have had was $3,062.61. That is your total balance after 3 years. If that's my total balance, how much money did I earn in interest? How much money did I make? My total balance after 3 years, guys, was $3,062.61. And I started with $2,500. What is the interest that I earned? The interest earned would be 3,062.61 minus my 2,500, which would equal, that's right, $562.61. And that's how much I earned in interest. That's how much I made. May not be the most exciting stuff, but it's not that difficult, and it's very useful. If you're ever going to buy a car, a house, finance anything at all in your life, these are the formulas they're using. Wouldn't you rather have a little bit of an idea of what your payment's going to be before you go in, right? You don't want anyone to steal from you. You don't want somebody to say that it's really X when it's really Y. A lot of people do that to consumers in this world. Consumers don't know any better, and they get robbed legally because you let them, because you signed the paper, you signed on the dotted line. You said yes to the wrong math. That's not illegal, is it? You agreed. That's why math is so important, my brothers. Yes, sir, my brother. The .07. Okay. The, very good question. Okay. What my boy asked here is, yes, this is compounding. What happens here, guys, is you get 7% of your original investment, okay? And that 7% gets thrown back into your balance. So now it's not paying on your original amount. Now it's paying on the original amount plus the 7%. Then it's going to take 7% of that value. Then it'll take 7% of that new total value. It kind of works like this. There's simple interest and there's compound interest, okay? Simple interest, just to make life easy, let's say that we have a $100 investment, okay? And it pays 10%. That doesn't exist nowadays, but that's a crazy good percentage. But let's just say that it's simple interest, and we have year one. Okay? Year one, 10% of 100 is $10. Now my balance is $110. Cool. But guess what? Year two, they pay you the same old $10. So my balance this time would be now 120. Simple interest, you only pay on the balance. So what you start with, that's what they're going to pay you on. Compound interest is much more powerful. And this is what we just saw. Compound interest works like this. You have the same $100 and the same 10%, but it's compounded. Year one's the same, guys. Year one doesn't matter. $100. You made your $10 in, sorry. Year one, you made your $10. Okay. And now your balance is 110. Cool. Everyone's happy. Great. Now, year two, though, guys, guess what? It's 10% of the balance. So in year two, you make $11. So you got 121. Now, some of you guys may say, Moro, that's nice and all, but you're talking about $1, dude. Who cares about $1, dude? Well, think about it, guys. This is for $100. Hopefully you guys are going to be investing with millions. So then it's not just $1, is it? And remember, $1 repeated 100 times is $100. So never poo-poo money, no matter how small it is. Does that help you understand what's going on here, my man? Thank you, sir. Is everyone with me on the same page? You good, Papa? Thank you, my brother. Okay, now, my cousin invested $3,000 into a savings account at the end of 8th grade. The account pays 8% annual interest. How much money will be in the account after 4 years when he is ready for college? Yes, sir, my brother. Yes, Y equals, I like your style, I like your attitude. 3,000 because that's the amount he started with. Great job, my brother. Yes, sir. Oh, yeah, because he went 1 plus the 8%, which is 0.08, but he went ahead and did it all together. So he said 1.08. Fantastic. To the 4th power because he knows that it's to the x power, and that's time, and that's 4 for this equation. Now here, guys, again, I'm going to let you use a calculator. Heck yeah, I will. Remember, I don't see the formula, I give you nothing. Okay? Anyone can use a calculator. It takes intelligence to set up the equation. So 3,000 times 1.08 raised to the 4th power, and that's going to be $4,081.47. Please be sure always to round to the nearest cent because we are dealing with money. Does that make sense, guys? It's not bad, right? It's not too bad. Looks ugly. A lot of words and percentages and stuff, but not that bad. How about this bad boy? How much money will I have after 5 years if I deposit $1,500 into a savings account, paying 2.75 annual interest? Okay, what's happening here? Okay, so y equals 1,500, parentheses. Ooh, nice. Not 3.75 though, be careful. I know what you did. You went 1, 2 though, remember. So it's 1.0275. I'm proud of you though because I know you had to add 1 to the rate. Just be careful. Make sure you always turn to a decimal, sir. And that's going to be raised to the, oh yeah, it's good stuff. So I got 1,500, touch parentheses, 1.0275. Close those parentheses, raise it to the 5th power, and ding dong, the witch is gone. $1,717.91 is your grand total. If you notice, it's not much you made. And that's a 2.75% rate. Just so you guys understand where we are right now, present day, okay? My checking account and my savings account pays me a whopping 0.02%. 0.02%. So that's 0.0002. Okay, so that means that for every $100, I get a big fat nothing. That's right. For every 1,000, I'll get 2 cents. That's the way it goes. So, that's the way it goes, guys. That's the interest rates right now. It's got low interest. Okay, so now next. How is this used in real world? Endangered species. The table shows the world population of Iberian lynx in 2003 and 2004. Very endangered species. Very endangered species. If this trend continues, the population is decreasing exponentially. How many Iberian lynxes will there be in 2014? Okay, let's think about this here, guys. In 2003, I had 150. In 2004, I had 120. There was a loss of 30, but I'm dealing with percentages. We're dealing with exponents. So how can I find the percent change here? Okay, good job, guys. Yeah, whoever said a percent change formula. Good job. Good job. Yes, and percent change formula. Yes, exactly. Good job. It's new minus old Great job, guys. Divided by old. And yes, exactly, times 100. Right, because I got to make it a percent. Good job, guys. So, we have my new amount is 120 minus my old amount of 150 divided by my old amount of 150. That gives me negative 30 over 150. So that's going to be 20%, right? Yeah. So that's a negative 20%, but remember, you can't have a negative. That just lets you know that it's a decrease. So this is a 20% decrease. Now, I'm not done yet though, because I want to predict now in the future. I said that if this stays constant, what's going to happen to the population? Well, y equals the original amount was in 2003. That's my A times a decay of 0.8, right? Because it's a 20% decrease. 100 minus 20 is 80% to the x power. I want to know where it's going to be in 2014. Guys, how many years from 2003 to 2014? Okay, so we have y equals to the 11th power, and that's going to be 150 times 0.8 raised to the 11th power, and that's going to be roughly 12.8. Unfortunately, you can't have, no sarcasm, 0.8 of any living thing. So we're looking at 12 left. No, you would not round to 13, not being sarcastic, because you can't have 1/8 of any living being. If it was a different situation, if you needed, my man, and this is a great question. Let's say we were talking about buses that we needed for a field trip, and you needed 12.8 buses. I need 13 buses, right? Because again, they don't have 0.8 of a bus, but that means that I'm using part of a bus. So that means I need one whole bus. Am I making sense here to you? But if in a living being, I have 0.8 of it, yeah, I didn't quite make it to that 13th. Okay? Does that make sense, guys? Thank you so much. Does that make sense? I mean, like, this is like, do you see the beauty for this, guys? I know that I'm a math dork, but does that make sense? Do you see how powerful that is? Okay. All right. Great job, guys. Now, sit up. Shh, guys, please. Now, the equations that we did were nice and beautiful, and we made them because we were using logic. But there are some exact formulas for compound interest. And compound interest is not always going to be nice and pretty the way we saw that. It's real simple. Sometimes what's going to happen with compound interest is you're going to have payments throughout, okay? Maybe they'll say that they're going to pay you interest annually or semi-annually or quarterly or monthly or yearly or daily. All of those are different number of times that they're going to apply the percent to your balance. So it's the number of times that your balance is going to grow. And the formula is A equals P times 1 plus R over N to the NT power. Guys, don't stress this. P is my original or initial amount. Same thing as the exponential. R is my interest rate. It's a percent, so remember I got to turn it to a decimal. N is the number of payments. I'm going to go over the number of payments in a second. And X is time in years. The number of payments, guys. If they tell you yearly, okay, or annually, N is 1. You get paid once a year. If it's quarterly, N is 4. You get paid 4 times a year. Monthly is 12. Daily is 365. Semi-annually is 2. Yes, sir.
Just so they don't get confused later, change the x to a t because the equation has the method as a t.
I'm sorry?
The equation, the method has a t, but now you have it as an x.
Okay, yeah. See, absolutely. They are interchangeable, but you're absolutely right. According to that formula, it's a t. Thank you, my brother. God bless you. Thank you. Does that make sense, guys? Yes? Now, let's put it to play. How much will you have in an account that pays 7% compounded semi-annually interest if you invest $3,000 after 4 years? Don't stress. Why? I love it when it does that. Okay, let's try it again. What do you guys think? 50-50? Oh, got lucky. Okay, y equals. Beautiful, guys. 3,000 because that's my initial amount. I love it. I love it. Now, 1, okay, you guys got that, plus 0.07 over 2. Thank you, guys. Be very careful. Look at what I did there. I did not go 1 plus 0.07 and then divide that by 2. No. It's 1 plus 0.07 divided by 2. That's separate entity, okay, guys? And then that raised to the 4th power. Be careful here in your calculator. Yes, to the n power. Thank you. So now, be careful in your calculator here, guys, okay? A lot of people do it differently. Some people, what they'll do is they'll go 0.07 divided by 2, and then they'll add the 1 eventually, immediately. And if that makes your life easier, you absolutely can. Some people like to do it all in one fell swoop. Doesn't matter, okay? But at the end of the day, we got 3,000 times parentheses 1.035 raised to the 8th power, and that's going to equal $3,950.43. Not bad, right? Now this next one I'm just going to set up right quick because I got one last thing to teach you. You guys got to go to lunch and then you want to get out of here. John invests $6,000 into an account that pays 12% interest compounded monthly for 3 years. Find the balance of this account. I'm just going to set it up. Help me out. Y equals 6,000. Great start. Times 1 plus 0.12. Yes, over 12 because it's compounded monthly. Raised to the 3 times 12 because it's paid 12 times. So at the end of the day, this will look like y equals 6,000 times 0.12 divided by 12. It's just 0.01. So 1.01 raised to the 36th power. And you put that into the calculator and you get your answer. Question, my brother? Last thing, real quick and easy as well. Continuous compound interest. Continuous means that it's literally paying you nonstop continuously. Every second of every moment of every day, of every hour. And it's A equals PRT. They call it PERT for short. A is the initial amount. R is the interest rate. T is time in years. And E is Euler's number. Euler is a pretty cool scientist that came up with this Euler's number that's used for a lot of applications in log and exponentials. It's 2.71 is the actual Euler's number, and it's used later for what's called natural log. But real quick, Julian invests $15,000 into an account that pays 8% interest compounded continuously for 5 years. Find the balance of this account. My balance will be A equals P the principal times E, which is a button on your calculator. It is right above the LN button. You're going to have to hit the shift button to hit it. E to the R, which is 0.08, times T, which is 5 power. So this would be 15,000 rather, times, parentheses, shift, hit your E button, then go 0.08 times 5, and your answer will be $22,377.37. Thank you for your patience. God bless you all. Hope you learned a lot. Have a great day. Bye-bye, guys.